Space is not just far away and cold, it's also silent. Sound waves need a medium like air to travel through, and space is almost a perfect vacuum. So when astronauts talk on the moon or other nearby planets, they have to use walkie-talkies and radio waves instead. But this raises an interesting question. If humans could breathe in space, would space still be silent? Or could we hear all those whispers of the cosmos that are just beyond our current perception? Hi, I'm here. Welcome to Weirdy World, where we try and answer the great questions of the universe, like what would happen if you breathed in space? Now, there's no easy answer to this. There are more holes in our understanding than in a block of Swiss cheese. So we're going to do something we don't normally do on What If. Take a trip to the future to find out how humans might evolve to breathe in space. Spoiler alert, it's gonna take some pretty major changes to make that possible. And here on Earth, we've got some pretty major changes happening already. Let's take a look at what it takes for us to breathe today. First, let's take a deep breath together. Feel your diaphragm move, pulling in air through your mouth and nose. That air travels down your throat and into your lungs, where oxygen passes from the tiny sacs called alveoli into your blood, which carries it to the rest of your body. At the same time, carbon dioxide moves the opposite direction into your lungs and then out of your body. This exchange of gases happens because the air in your lungs has a higher concentration of oxygen than your blood does. And oxygen naturally moves from high to low concentrations. Your blood, having inhaled all the oxygen it needs, then returns to your lungs where the process starts again. But why do we need all this complexity? Why can't we just absorb oxygen directly through our skin? Well, think about it. Here on Earth, all the air we breathe is about 21% oxygen, with the majority of the remaining air being nitrogen. All that nitrogen is actually pretty useful. When we inhale, it dilutes the oxygen, giving us a nice gradual intake of the gas we need. Plus, the pressure created by the nitrogen helps keep our lungs inflated. In fact, if we were to replace the nitrogen in our atmosphere with something less dense like helium, we'd literally begin to float away. It'd also be much harder to breathe, so aside from the composition of the atmosphere, Earth's gravity also plays a huge role in breathing. Gravity pulls air molecules down onto us, creating the pressure we need to push air into our lungs. But even with gravity's help, we'd struggle to breathe if we didn't have a flexible rib cage and lungs to expand our thoracic cavity and draw air into our body. Oh, and speaking of Earth, there's one more thing we need. While our bodies extract oxygen from the air we breathe, we also need water to remove the carbon dioxide component of breathing. Every time we exhale, we're also exhaling some water vapor. But here on Earth, that's not a problem. The moisture we lose is replaced by the liquid water all around us. But in space, things would get very dry very quickly. So to breathe in space, we need all those pieces to change. We need an atmosphere to breathe. We need gravity to push air into our lungs. We need water to expel carbon dioxide, and we'd probably want some protection from radiation too. Now, these are big issues, but in the far future, maybe not insurmountable ones. For example, we'd probably want to stick with a nitrogen-oxygen atmosphere, so we wouldn't suddenly start floating up to the sun. So we'd have to bring along some nitrogen. Then we could use centrifugal force to create artificial gravity. And NASA has already developed some ways to recycle urine into drinking water, though we'd probably want to find a more elegant solution for the long term. As for radiation, well, we'd want to live somewhere where it wasn't a constant problem, like on the sunny side of an asteroid or a moon that's tidally locked to its star. Even with all those changes, we still haven't addressed the most basic requirement to breathe in space, the need for a pressurized environment. Like we talked about earlier, air molecules travel from areas of high pressure to low pressure. Since space is a near vacuum, there's almost no pressure pushing down on us. If we were to step outside without a spacesuit, the air in our lungs would expand and rupture our alveoli. Even if we could manage to inflate our chests with air, every exhalation would be a lungful of deadly void. However, there is a way to solve this. Near any large body of water, there are places called seeps where water bubbles emerge from the depths and float to the surface. These bubbles are full of dissolved gases, including oxygen. They form because the water at the bottom of the ocean is under intense pressure, which forces gases from the surrounding environment to dissolve into it. When the water rises, the pressure drops and the gases, unable to stay dissolved, form bubbles and escape. It's basically the opposite of what happens when you open a bottle of soda. But the key here is that these underwater bubbles have enough pressure inside them to keep expanding as they rise to the surface. By the time they reach the top, they're several times larger than they were below. This same principle can be used in space. Imagine a container of water on a spaceship. As the ship travels through space, the water in the container experiences immense pressure from all sides. All the molecules on the outside of the container are pushing in equally. Because there's nothing on the inside of the container pushing back, the water is compressed. If we punched a small hole in the container, the water would shoot out of it like a rocket, expanding rapidly as it leaves the ship. The further the water travels, the lower the pressure, and the more it expands until it becomes a giant bubble. So if we could build a self-contained environment that was pressurized with water, we could breathe inside it while outside the ship. The water pressure would prevent our lungs from collapsing and provide the push we need to breathe. We'd probably need some kind of mask or helmet to force our faces into close contact with the bubble, and we'd need thick gloves to keep it from bursting when we touch it. But we could see our hands and each other's faces again, and we could talk, not with walkie-talkies, but face to face. Of course, none of this is easy, but it's also not impossible. Scientists have figured out how to pressurize water with massive amounts of carbon fiber to create powerful rockets. And on the International Space Station, experiments like Veggie have figured out how to grow plants in space. With some more ingenuity, we should be able to figure out how to breathe in space. But would we even need to wait until we evolve to breathe in space? What if we invented a way to do it first? Well, there's some intriguing possibilities there. In 2016, a group of engineers and scientists published a plan for a device that would allow humans to breathe in space. Basically a backpack with tanks of water on either side, one pressurized and one depressurized. The user would don the backpack, don a helmet and a pair of goggles, and breathe through a tube attached to their helmet. As they inhaled, the pressure in the backpack's tanks would equalize. Then as they exhaled, the carbon dioxide in their breath would trigger a valve that released water from the depressurized tank into the air pocket in the helmet. The CO2 in the air pocket would react with the water, forming carbonic acid, which would then pass through the astronaut's skin into their bloodstream, where it could be expelled through their kidneys. The exhaled breath would then be pumped back into the pressurized tank to be reused. It sounds complicated, but it solves all the problems we mentioned before. The water tanks provide both pressure and the oxygen we need to breathe. The air in the helmet has a mix of oxygen and nitrogen. And because it's in direct contact with the user's skin, it would pick up some of the excess heat produced by their metabolism. It wouldn't be perfect, the device would be heavy and bulky and require frequent maintenance. But it could work. It wouldn't even be the first time someone had tried. In the late 1970s, NASA's Biospherics research team developed a prototype of this device for their biosphere to experiment, an attempt to create a closed ecological system that could sustain human life. Though it ultimately proved unnecessary for the project, the device was tested in the Arizona desert and was deemed safe and comfortable to use. As hopeful as these inventions are, though, we shouldn't ignore the elephant in the room. Breathing in space would mean leaving Earth behind. And for better or worse, that's something that hasn't happened yet. Space travel is still expensive, difficult, and potentially dangerous. So for now, we won't be breathing in space anytime soon, at least not without our helmets and suits. But that doesn't mean we shouldn't keep trying. After all, we might be missing out on some pretty incredible sounds. We know that sound travels as vibrations through a medium like air or water. But what kinds of vibrations are we missing out on in space? One obvious one is the hum of stars. Some stars vibrate so much that they actually make audible sounds. If we could hear those sounds, space might not be silent after all. But there are also the sounds of the solar wind, particles of plasma constantly streaming from the sun, whipping past the planets and moons, passing their atmospheres and vibrating their surfaces. There are even supposed to be giant space-based shock waves caused by the solar wind interacting with our magnetic field. All of this is completely beyond our current range of hearing. But if we could hear it, space wouldn't be silent anymore. It'd be alive with noise. Thanks for watching this episode of What If. I'd also like to give a huge shout out to our community who made these amazing videos and asked these thought-provoking questions. We couldn't make What If without you, so thank you. And if you want to join our incredible community, head over to our website. This is the second part of our series, Part 2, Rewriting Human Biology. If you can breathe in space, life on Earth changes dramatically. Your lungs have the ability to extract oxygen from the thin Martian atmosphere. You can stay up there as long as you want without an oxygen tank. And here's the crazy thing, if you could breathe in space, you could also breathe underwater. Imagine scuba diving in the ocean, but instead of coral reefs, you're surrounded by alien plants with neon green seaweed and bioluminescent phytoplankton. You could hang out with sea cucumbers, sea lily, and even the elusive anglerfish. No more scuba gear, just you and the endless wonders of the deep sea. It's like being a spaceman without the helmet. Underwater cities could become a reality. Who needs air when you've got water? Imagine homes built into coral heads, complete with glass domes for viewing the ocean around you. You could watch dolphins play outside your window and sleep to the rhythm of the waves crashing against the reef. Life underwater could be the ultimate adventure. Cities could build artificial reefs, turning them into bustling metropolises of the sea. Skyscrapers made of concrete and steel would be replaced by towers of coral and kelp, swaying gently in the current. And instead of cars, we'd use sea scooters to zip through the water. No roads, just clear highways of blue. And it's not just about exploring new frontiers. Breathing in space and underwater could also help us survive on other planets. If you can adapt to Mars, you could skip the bulky spacesuits and explore the red planet freely. You could feel the wind in your hair as you walk across the rusty landscape, discovering new life forms and maybe even some signs of ancient civilizations. Who knows, maybe you'll find a Martian oasis with palm trees and a secret colony of friendly aliens. No more relying on canned oxygen or risky asteroid mining missions. If you can breathe in space, you could live in space. Expand your lungs and discover new worlds. With each breath, you bring Earth's atmosphere with you, creating a bubble of familiarity in the vast emptiness of space. No more struggling to adapt to alien environments. You are the environment. Space travel would explode literally and metaphorically. No need for pressurized suits, no need for oxygen tanks, no fear of suffocating or freezing to death. We could hop onto small spacecrafts with open tops, like cosmic scooters, zipping from moon to moon. Space tourism would become a weekend getaway. Instead of beach resorts, imagine orbital retreats where families float outside space stations, holding hands and watching Earth spin below. The sky wouldn't be the limit. It would be the beginning, but wait, there's more. Breathing in space also means conquering another frontier, the vacuum of intergalactic space. No more air, no problem, just pack your bags and blast off to distant galaxies. Travel time between star systems would shrink from years to mere days. Galactic empires could become a reality. As humanity spreads its wings and flies to new frontiers, breathing in space and underwater changes everything. It opens up a world of possibilities that were once the realm of science fiction. From underwater cities to interstellar travel, the only limit is your imagination. So what do you think? Would you want to be able to breathe in space? Let us know in the comments below. What if we could breathe in space? Part 3, Earth Reimagined. If humanity could survive in space, our largest cities would shrink dramatically. Metropolis, New York, Tokyo, London, these densely packed hives of industry and culture would become unlivable. At least that is unless we drastically reduce our population. The world's biggest cities would need to become the world's biggest nature preserves. Skyscrapers would become bird sanctuaries and sprawling suburbs would become wildlife refuges. Of course, some people would still want to live in the concrete jungles, at least at first. But as more and more people left, the cities would fall into disrepair. Within decades, they would become overgrown jungles. Within centuries, they would become ancient ruins. Within just a few generations, Earth would look like a post-apocalyptic wasteland. That is, unless we could somehow keep our cities afloat, literally. What if massive portions of the world's largest cities were torn from their foundations and placed into orbit? These floating colonies would have all the amenities of the original cities, but without the crushing crowds. They might even have better views. Imagine living in a high-rise apartment in Neo-Tokyo or Old London and stepping out onto your balcony to see the entire Earth curved against the backdrop of stars. Of course, building floating cities would require a lot more than concrete and steel. We would need to completely rethink our concept of architecture. The old buildings wouldn't cut it. They'd simply collapse into a tangled mass of twisted metal. Instead, we would need new structures designed specifically for zero gravity, buildings that could stretch for kilometers without any support, buildings made of glass. These massive domes would span enormous distances, perhaps even thousands of square kilometers. They would contain everything necessary for human life, including artificial gravity generated by rotating sections of the dome. Inside, we could recreate any environment imaginable, from tropical rainforests to rolling grasslands to bustling cities. Outside, we could gaze out at the stars and watch the Earth rise and set in the black sky. It would be a paradise for star lovers and a nightmare for insomniacs. But what if we didn't stop there? What if we used the Earth's atmosphere as a building block? With current technology, we can already manipulate gases in outer space to create artificial atmospheres. All we need to do is find a large enough space and then seal it off from the rest of the universe. With trillions of cubic kilometers of space available in our solar system, the possibilities are endless. We could create massive bubbles of breathable air in the vacuum of space, giant soft spheres floating among the stars. In these bubbles, we could live out our wildest fantasies. We could build sprawling communities, glass-enclosed gardens filled with exotic plants and animals, even artificial suns to light our way. And gravity would be optional. People could float between floors, dance in the air, sleep while gently falling through space. There would be no up or down, no left or right, only endless possibilities. At first, these bubbles would likely be used as habitats by intrepid explorers and daring colonists. But over time, they would become the homes of entire civilizations. Imagine a bubble city colonized by thousands of people, complete with its own government, economy, culture, and society. There would be no walls or borders, no rich and no poor, only a community of equals working together to survive and thrive in the harshest environment imaginable, the vacuum of space. As more and more bubbles were created, our solar system would become a constellation of floating cities, each one a testament to the ingenuity and adaptability of the human species. And when people looked up at the night sky, they would see not just stars, but a reflection of themselves. So what if we could breathe in space? For some, it would mean freedom from the constraints of our planet. For others, it would mean the chance to build a new life among the stars. One thing is for sure, it would mean the end of Earth as we know it. Part 4. Cultural evolution. If we found a way to breathe in space, life as we know it would change. In our previous episodes, we talked about how our bodies would evolve, specifically our lungs and muscles. We also discussed how our architecture, clothing, food, and language would change. Now it's time to talk about culture. Our entire culture would shift in a big way. For example, music in zero gravity would sound different. That's because the very essence of musical instruments relies on air molecules vibrating at certain frequencies to create sounds. A flute, for instance, produces sound when air is blown across an opening, causing the air inside to vibrate. But without air, how could this process occur? Imagine sitting on a space station orbiting Earth, gazing out at the stars while listening to music composed specifically for zero gravity. The music might have a slower tempo, utilizing the unique acoustics of space to create haunting melodies that echo the vastness of the universe. Movies, too, would be filmed in space. Think about it. A huge draw for space tourism is the chance to experience weightlessness. So why not make movies in orbit? Studios could build special sets that utilize the freedom of movement offered by zero gravity. Action scenes would take on a new dimension. Literally, it would no longer be bound by the laws of physics on Earth. With the right visual effects, these movies could feel truly epic, taking full advantage of the backdrop provided by the stars and planets. Education would be another area greatly affected by our ability to breathe in space. If we could survive in space, then space travel would become commonplace. It would no longer be restricted to a select few astronauts. Everyone could experience it firsthand. So it stands to reason that space training would be included in school curriculums from an early age. Kids would learn how to push off walls to move around, how to land without falling, and maybe even how to navigate asteroid fields. Textbooks would be rewritten to include information about space travel and survival. Field trips might take us to the moon instead of the zoo. And career options would expand to include spaceflight. Teachers would need to be trained in zero-gravity education techniques, and schools might have special areas that simulate different gravity environments, from the moon to Mars and beyond. Learning would become a galactic adventure. Religions, too, would go through an evolution. Some might develop a strong connection to the stars, seeing them as sacred homes of their ancestors or divine points of light left by gods in the sky. Constellations might take on new meanings and myths. People might turn to the stars for guidance or comfort, finding solace in the belief that they are connected to something greater than themselves. Religious art would likely change to reflect this new perspective. Churches, mosques, and temples might be built with domed ceilings to evoke the feeling of lying on a cold, hard floor, staring up at the vastness of space. Religious leaders could incorporate stories of space travel and alien encounters into their teachings. Religious music might change its tempo to match the slow, haunting melodies of space. In general, art in all its forms would likely be greatly influenced by our perspective of the universe. Artists would now have a whole new world to explore and express themselves. Painters might capture the breathtaking view of Earth from space, while sculptors could create pieces that mimic the swirling patterns of nebulae. Writers might find inspiration in the silence of space, composing poetry under the rings of Saturn. Theater could take on a new dimension, literally, with performances that utilize the freedom of movement offered by zero gravity. In short, our ability to breathe in space would open up a whole new world of possibilities. It would force us to rethink everything we know about the universe and our place in it. It would challenge us to push the boundaries of what we think is possible and expand our understanding of the world around us. So the next time you look up at the stars, remember that they hold endless potential. Who knows what wonders await us among the planets and galaxies? What other changes can you think of that would occur if we could breathe in space? Part 5: Unexpected Challenges. It would open up interstellar travel, colonization of other planets, and many other exciting things. But what if we take it one step further and imagine that a person who can breathe in space has been in it for so long that they start to consider it their home? What are the inconveniences, dangers, and problems they will face if they want to live in space permanently? Let's find out. If you're watching this video for the first time, be sure to watch parts 1, 2, 3, and 4 to find out how the ability to breathe in space would change our world. A person without a spacesuit is defenseless against space. Without air, without water, without protection from cosmic rays and meteors. It's a harsh reality check for anyone who thinks of themselves as the king of the universe. To survive in such conditions, you need technology. You need something to protect you from external influences. And it's not just about creating a suit that would allow you to move around comfortably. It's about protecting your future colony from deadly cosmic rays, meteor showers, solar flares, temperature changes, and magnetic anomalies. First of all, you need a base or station protected from all of this. In space, there's no air to absorb and reflect sunlight like on Earth, so temperatures can reach 120 degrees Celsius during the day. At night, they drop to 120 degrees below zero. Such a difference in temperatures in one day requires serious thermal insulation. For comparison, modern spacesuits have a thermal insulation layer equivalent to a down jacket, with 15 centimeters of material. They allow astronauts to operate outside the station at 18 degrees Celsius. So it's clear that for permanent residents, we'll have to look for new solutions. One option is a dome made of transparent conducting polymers. This material would simultaneously protect its inhabitants from meteorites, radiation, and extreme temperatures. The dome will let sunlight through, but it'll also generate electric current from it. Solar panels that cover the roof of the dome will convert solar energy into electricity. Electricity that can be used to grow plants and power household appliances. Plants will need artificial lighting to grow, which means the domes will need to collect and distribute light evenly. In addition, they'll need to maintain a balance of carbon dioxide and oxygen, plus pressure, temperature, humidity, and gravity. It's not easy. The good news is that scientists are already working on these issues. For example, NASA has calculated that to maintain a comfortable climate inside a dome on Mars, it would take 200 solar panels for every 100 square meters of the dome. That's enough for an average family. Scientists have even considered how strong the walls of such a dome need to be to withstand meteorite impacts. The calculations show that the material must withstand an impact of 10 to the minus 7 kilograms per second squared. A small price to pay for the opportunity to walk outside without a spacesuit. But it's still worth remembering that even with all the benefits of technology, life inside a dome will be severely limited. You won't be able to walk barefoot on the grass, breathe fresh air, feel the wind, or watch clouds float by. Perhaps we'll be able to recreate a piece of nature inside the dome. But if you think about it, it's not just the environment that's important. When people are isolated in an enclosed space for a long time, they start going crazy. For example, during the Apollo 11 mission, Neil Armstrong and Buzz Aldrin spent 2 days in orbit on the command module with Michael Collins. After returning to Earth, they were interviewed separately, and it turned out that they had completely different memories of what had happened. Moreover, Armstrong and Aldrin remembered some events that never occurred. They simply imagined them. It is hard to say whether the astronauts were affected by the confined space or whether it was stress caused by the flight. But one thing's for sure, they needed to get away from each other as soon as possible after landing. After the Gemini 6 and 7 mission, 3 astronauts spent 2 weeks in a space capsule. The crew suffered from severe claustrophobia and couldn't sleep. All of them lost weight, although none of them went on a diet. The appetite of the crew members disappeared altogether. By the end of the flight, the atmosphere in the spacecraft was so tense that Frank Borman suggested opening the hatch and letting the others float away into space. Of course, nobody did that, but it shows just how hard it is for people to coexist in such close quarters for a long time. So if we talk about living in space, then the colony must not only be protected from the effects of the external environment, it also needs to ensure the mental health of its inhabitants. The problem is that at present, it's unclear what exactly would cause psychological problems in space, so we can only guess how to deal with them. It seems like one of the most important things for a person is to have personal space. Even in prison, cells are equipped with 3-tiered bunks so that prisoners can hide under the covers and be alone with themselves. Astronauts in the ISS cabins are separated by curtains. People need to be alone with themselves sometimes. So the colonies should provide for that. Another important point is communication. When astronauts are interviewed about their experiences in space, they often mention how much they miss ordinary human communication. They mean communication not just with other astronauts, but with people on Earth. For this purpose, colonists will need fast and, most importantly, cheap communication tools. Video calls will help maintain relationships with families and friends, but it lines also allow them to see what is happening on Earth and feel like they are part of it. These are just a few of the problems that arise when we talk about living in space. There are probably many more, and we may not even know about them yet. After all, we haven't sent anyone into space for so long that they wanted to stay there forever. But even despite all the difficulties, it's hard to argue with the fact that this will be an incredible adventure. Imagine being able to see the beauty of the universe with your own eyes, seeing galaxies millions of light years away from Earth. No telescope can compare with what a human eye can see. But what if a person breathes in space, feels great there, and doesn't need any protective equipment? Wouldn't it be easier to live on other planets? Take Mars, for example. Its atmosphere is mostly carbon dioxide, but it contains almost 2% of oxygen. If we add a couple of percentage points more, it'll be easier for us to breathe there than on Earth after a couple of beers. And the pressure on Mars is only 600 kilopascals. On Earth, it's 1,000. That's why cars on Mars won't have an air filter. Or maybe we lions be able to dispense with those complicated spacesuits and just wear something like diving suits. Part 6. The future is us. If we could breathe in space, we wouldn't just be Earthlings anymore, we'd be citizens of the universe. We could establish colonies on Mars, outposts near Jupiter, and expedition ships could sail to galaxies far beyond our own. There would be no more boundaries, no more obstacles between star systems, just one big, beautiful universe full of possibilities for us to explore. Perhaps one day a child will be born among the stars who has never set foot on Earth. They would look up at the blue planet in the sky and ask, what was it like? The blue planet and we, the people born under the stars, would smile and breathe in the star-speckled air and say, beautiful. But out here, we found something more. We found something more. That's right. Because if we could breathe in space, we would truly learn what it means to live without limits. Without limits. Imagine what it would be like to gaze up at the night sky on a clear, crisp evening and not see a sky full of stars, but a sky full of worlds. Each twinkling point of light, a world in its own right, possibly teeming with life or just as likely, not. If we could breathe in space, we could explore these worlds without the need for bulky, cumbersome spacesuits that limit our movement and our vision. We could soar through the cosmos in sleek, aerodynamic ships that would feel like an extension of our own bodies, allowing us to reach out and touch the stars. If we could breathe in space, we could build new homes among the stars, colonies on Mars, research outposts on moons of Jupiter, tourist havens on the rings of Saturn. We could become a multiplanetary, multi-system species, no longer confined to this tiny blue dot in the vast expanse of the universe. If we could breathe in space, we would truly be free. Free to explore, free to discover, free to build new lives among the stars. It might seem like a far-fetched fantasy, but the truth is, anything is possible. If we set our minds to it, we can overcome any obstacle, any challenge that stands in our way. So let's keep reaching for the stars, dreaming of the day when we can breathe in space and explore the infinite wonders of the universe that await us. What do you think? Would you like to be able to breathe in space? Let me know in the comments below. And if you enjoyed this video, don't forget to leave a like and subscribe for more videos like this in the future. Thank you for watching. See you next time.